All right, we have worked our way around the rock cycle, and now we come to metamorphic rocks. These rocks may seem nice, but they've also been around the block and seen some schist. So let's get on with this video so I can show you exactly what it is that I mean. Foliated metamorphic rocks are so called because of the alignment of the minerals that form into these nice little lines, which geologists call foliation. Foliation happens when a rock experiences a lot of pressure in one direction, so like a lot more pressure on the sides than the top and bottom, for example. I bring this up because with sedimentary rocks there's compaction, which forms the rock, and this is from equal pressure on all sides of the rock. But foliation comes from unequal pressure on the sides of the rock. So if we look at these rocks, which are granite, we can see that the mineral grains are going every which way, right? But as unequal pressure is exerted on these rocks coming from the left and right directions, we get foliated metamorphic rocks. So let's meet those rocks. First, here is slate. This rock comes from shale, which has been put under even more pressure than it was when it formed the shale. This pressure has made all of those grains squished together tightly, and the tightest they can get is when they're parallel to each other. Sort of. We'll see if they can get even tighter in just a second. That makes slate kind of like biotite or muscovite micas because when the slate breaks, it breaks parallel to those grains, which are all parallel, right? And so it breaks into these nice sheets. Okay, so what happens when you put that shale under even more pressure? Well, you get phyllite. So with more pressure comes friction, and friction generates heat. So now we have enough pressure to generate enough heat to partially remelt those mica minerals, which means they can grow into a little bit bigger crystals. And remember that biotite and muscovite micas are shiny. So when they get bigger, they can get shinier too. Okay, so remember how I said that parallel minerals are the tightest that they can get? Okay, well, phyllite is a little bit tighter, all right? Those sheets are a little bit irregular, and that's because that pressure has taken those nice little parallel mineral grains and squished them even further into these curvy parallel mineral grains. So they take up less space on the sides where the compression happened. Okay, now we have schist. This rock has been through some serious pressure. These crystals have remelted a little and have formed into visible crystals. You can now see the different crystals with just your naked eye, not just their shiny luster. And the minerals are all compressed and flattened along one plane. We call this a scaly texture. Can you see how this sample looks kind of scaly? All right, so saving the nicest for last, we come to nice. Yep, that's how you pronounce it. And it has a really nicely defined band of minerals, which are all generally oriented opposite to the plane that experienced the highest pressure. Okay, these minerals have been through a lot. They have remelted to the point where they were mobile enough inside the rock that they were able to glom together and grow larger crystals. Okay, you've seen it. So, what doesn't kill you makes you nicer. Sorry, I couldn't help myself.